Right, we've looked at basic use of the bibliography in BibTeX. Now let's take the next step and look at some advanced use, which you may not want to do at first, but at some stage you may want to move to. Let's have a look at the notes. And the first issue is, how do you collaborate with BibTeX? And the problem here is you've got your own personal database of articles and books that you want to cite. Your collaborator has got their own database. There'll be some things which are common, but there'll be a lot that's different. Your collaborator will want to cite things in his database which aren't in yours. Or, another collaborator, and she'll have a third database. How do you make any coherent sense out of all these different databases in the one document? Okay, so when you start to collaborate, you need to come back to this. Now, it's only really efficient to do the following sort of thing. And this following procedure allows you to merge the database information from collaborators as an ongoing process. Right. First is to ensure that your computer system has an operating system script called bibexport, or it might be bibexport.sh. Right. So for example, it comes with most LaTeX systems, certainly in Unix. Ensure you've got access to it. Now let's have a look at the scenario where 3 people are collaborating. Say you are Alice and you've got collaborators Bob and Eve, and you each have your own separate bib files. Now I recommend your bib files be named something unique to you, so this will help with collaboration. So that's why I call my bib file ajr.bib. So let's suppose each person's bib file is alice.bib, bob.bib and eve.bib. Whatever, as long as they're unique. Then in your LaTeX source, wherever you run the bibliography command, put in 3 bibliography commands and comment out 2 of them. So that when you, as Alice, LaTeX the document, the bibliography command for you is this one, bibliography bibexport Alice. When your colleague Bob gets it, he will uncomment this line, and he will use bibexport.bob, and you'll also have to comment out your line. Oh, pretend it's you, execute LaTeX on the source, then say it's doc.tech. It generates a doc.org file, and then you execute bibexport.doc, usually via some terminal application. Okay, what that'll do, it will merge into a local file bibexport.bib, the necessary bib information from itself first, and secondly, from alice.bib. This means that, if sometimes you'll have already got stuff in the bibexport.bib file, and so you'll get warnings about duplicated bib entries when it looks up alice.bib, because it's already in bibexport.bib. Right. So the point is, bibexport.bib is sort of a common file for you all that contains all the merged information from the various authors' bib files. So once you've done a bib export, you can then do a BibTeX doc, and that'll generate, as usual, the bibliography in the doc.bdl file, and away you go as usual. So you work on your desktop and LaTexing, bibtexing, updating, rearranging, whatever. When you're happy to pass it on to your co-authors, you do a final bib export dot, right? That updates the bib export.bib file, and then when you send the new source file to your collaborators, you also send the new bib export.bib. Right? They will do whatever they do, their editing, their citation, and whenever they cite something which isn't already in bib export.bib, they will, their bib export will bring that information into the evolving bib export.bib file, and it will gradually get bigger and bigger, and it will get us a database of citations for that particular document from all your databases of all the collaborators. Okay, so that's how you can automate merging all those bibliographies. You can make it a bit more automatic by, instead of having this business of commenting out and in these bibliography statements, you can actually make it automatic by using if file exists command, right? Put this in the source, and then if you as Alice run LaTeX over this file, and if you've got a .sty file, then because that file exists on your system, LaTeX will execute that command. But you probably don't have, and hopefully you don't, have a bob.sty command, in which case that file doesn't exist when you run it, and so LaTeX will not run that command. And similarly for eve.sty. However, when you send the source to your collaborator Bob, he's got a file such as bob.sty, and so when he runs LaTeX on the source, his LaTeX will execute that command and not any of the others. And we'll talk about style files later. All right, what about gathering bibliographic data? First thing to realize is to use Google Scholar when you search for articles. Do not just use Google or other web search engines. Google Scholar is specifically for searching for research articles. Once found on the internet, there are things like Mendeley or Zotero, which help you download the information. I use Zotero. So let's suppose I'm looking for information about that. Then in Google Scholar, I would say, hey, what do you know about articles with that title? It comes back with the answer, oh, we know this exists. And it's published in, well, it's published by authors Roberts and Cronin, published in Physics A by Elsevier in 1996. So you click on the hyperlink and you go there. And to download the bibliographic information, I click on this icon at the top, which is the save to Zotero thing. And it downloads, and if it can, it downloads the PDF as well. It's thinking about it. Taking its time. No. So where's Zotero gone? Anyway, you then look in Zotero and you find that it's saved the bibliography information in a format that's a good basis for starting. I won't show you that now because something happens to it. Okay, you can then export it, save it into your, edit it, save it into your big file. It almost always needs editing. None of these automatic generators do a particularly great job. They do an okay job. Okay, what else is more advanced? Well, biblatex is replacing bibtex. It's just that your mature age colleagues need to be dragged into the modern world, and journals are still in the old world of bibtex. Biblatex is a more powerful and flexible method for citations, and in execution, you follow the usual LaTeX, bibtex, LaTeX cycle, and if necessary, bib export. But you do bibliography style and you do bibliography a bit different. So, to use the biblatex package, in the preamble, you use this command, something like this command. Mainly to say use biblatex and use it with options as I've got here. And the back end is bib equals bibtex 8, may or may not be necessary. Try it with and without, and if it works without, leave it out. If you prefer Harvard-like citations, use style is equal to author year. This replaces the bibliography style. If you need to use the Vancouver-like square bracket in numbers, use style equals numeric. Backref equals true is a nice optional thing to use. So that says to use biblatex and the style of the citations. The bibliography command you still use, but it no longer says where to put the bibliography. It only says where to find the bib files. So put it in the preamble, get it out of the way. And then wherever you want the bibliography, put \print bibliography. Now, I've got something a bit more sophisticated here. I've said almost always we want the bibliography to be right at the end. So we can tell LaTeX to do that. We can say at the end of the document, execute \ragged_right \print bibliography. And I recommend ragged right because these days bibliographies have some rather long items in them. They have URLs or DOIs, and these can be rather long and they ruin the line breaks. And the only way to reasonably rescue the line breaking algorithm is to say typeset and ragged right. Okay, you can put this in the preamble. So you can group all of these commands together in the one place, and you know that's where all your bibliography stuff is. Now, speaking of DOIs and URLs, DOIs are preferred over URLs. So if you're going to choose one or the other, choose DOIs wherever possible. If you've gathered a database of both in your database, and then typeset the DOI and ignore the URL. Now, unfortunately, that is not done by default. So if you only want to print the URL if there's no DOI, you can put those commands into the preamble as well. Now, there is a catch. And the catch is the following. The designers of various bibtex packages have not been consistent. Right? The principle of LaTeX is that there is one logical command which generates the typeset output. And if you write a package which is going to be a more sophisticated version of that logical command, you should still use the same logical command to make it easier for your user. Unfortunately, that is not what's happened for the bibliography. People who've written these more sophisticated bibliography packages generally have required you to use different citing commands. And it's such a pain. So, what do? Basically, I recommend you use biblatex. So the sensible thing is to map other formats of citing commands to the biblatex ones. And the biblatex ones are \textcite and \parent_cite. So use them, and then especially for colleagues who are using other versions of the citing command, like cite T and cite P, which one package does, or the old \cite, which I still use. You've got to get the source, the LaTeX source, to translate the old habits of your colleagues into the modern biblatex commands. And we do that in the following way. A couple of let statements will do that. And then a bit more sophisticated is for the old \cite command is to do that little rule. Include that in the preamble as well. Okay, so that's the end of citations. I've got one extra thing to slip in here. How do you handle large documents? If you're just writing a research article, that's really not large enough for a large document. You know, sort of 50 pages, even up to 100 pages isn't large. But once it gets over 100, that's getting into the large size. And you need to do something like this. LaTeX gives you a facility to split the text file into manageable chunks so that you only deal with one chunk at a time, both for editing and for typesetting. So let me show you that. Fractals25.tech is here. So this is now the main file of a large document. Of course, it's not very large, it's quite a short document, but let's pretend it's large. Okay, so it's the document class, the preamble, the title info. Then the begin document, end document has just got 3 include commands. Right, and these say include the source from that file, then include the source from that file, and then include the source from that file. So what are those sources? Let's get them. So here's Frac25. This is the title, the start of the document. The make title, the quote, the abstract, table of contents. You know, in your dissertation, for example, it would be all the front matter. Table of contents, abstract, acknowledgements, that sort of thing. 25B is the first section. Right, so if I just want to work on the first section, I just work on 25B. 25C is the second section, together with whatever it is that we put at the end, including the bibliography. Right, so we've broken up the source into 4. The main content is in 3 bits, and there's 1 master file. Okay, now if we just typeset this master file, let's do that twice to get all the auxiliary information correct. Here it is, and you'll see it's pretty much as before. There is one difference, and that is each include statement starts a new page. So this is suitable for chapters, but not really for sections. We'll live with it just for the moment. Okay, so you've still got the same document typeset. Now, suppose we're working on the first section. All right, we're doing lots of editing, typesetting, seeing how it looks, etc., etc., etc. What we can do is, in the main file, we put the command include only frac 25b. That's the source file of that first section. Save it, typeset it. Now, what's typeset is only the first section, as you can see here, right? There's nothing before this first section, and there's nothing after it. So it was typeset very much quicker, which means our production schedule is more responsive. We can get on and be more effective, smarter. Now, note the cross-references are all resolved, right? So here we had, in section 2, we had a reference to section, sorry, in section 1, this one, we had a reference to section 2. That cross-reference still works, and that's because LaTeX has written the information in the auxiliary file, and when we run LaTeX, it picks up that information, even though it does not typeset section 2. It gets the auxiliary information from when it last typeset section 2. So all is good. So yeah, I mean, we can add stuff in here to our heart's content. Play around with, play around with the enumerated lists. That's always good, clean fun, isn't it? Let's take this enumerated list and plonk it in the itemized list, and then take that itemized list and put it in the enumerated list. But don't typeset that. I've just told it to typeset frac 25b, and it can't because it's not a doesn't have a document class. Right? When you typeset it, you've got to remember to go back to your main document and typeset that. Okay, so there we are, and we've played around with the lists. We made the lists of lists and things like that. Whatever the edits happen to be. Okay, so that way in your dissertation allows you to work on one chapter at a time, usually. Oh, there's one last bit of information. Appendices, how do you do them? You just say \appendix before the first appendix, and then you use chapter and/or sectioning commands as before, and they will just get labelled as if they are appendices. Right, but the sectioning command is the same. So, do remember to cross-reference. It does take a bit more work, but you will quickly get used to it, and it pays big dividends in making things robust when you come to editing. Move information around, creating articles from a dissertation, creating a dissertation from an article, working with colleagues, and so on. Okay, so that's the end of our cross-referencing.